of the student in discrete mathematics getting problem in the group theory. But group part, if you understand this, this is the simplest part of this abstract algebra or the discrete algebra. Now, we are trying to simplify this group theory using the examples. To discuss with group, first we have to start with the binary composition. Actually, the term is not known to us, but we already know that the binary composition. You can ask me why. Now, I will write down some of the binary composition, then you will tell me you are completely unknown to this part or not. Plus minus product. I think all of you are familiar with this signs. These are known as the binary composition. Binary composition or binary function. When we add, we have to add this two numbers, or generally you can take 2 plus 3, that is equal to 5. 2 minus 4, that is equal to minus 2. 4 into 6, that is equal to 24 in this way. So, that means binary composition means nothing but your operation. Which operation? You already know that. Now, how we will define this then, the binary composition? If F is a mapping from, now 2 is, we know that 2 is a real number, 3 is also real number. As we are taking two real numbers, that means we are taking the ordered pair of real numbers. And after this addition, this is goes to a single number. That means this is goes to a single real number. Now in the place of F, we remove this F and we mark it with this plus. So this is called the binary composition. This is means binary composition is a mapping which maps R cross R to R. Or you can say Z cross Z to Z. As we know that the sum of the two integers is always an integer, right? Now, when we write down this Z, comma plus, and before writing this, we have to know the term closed under. Now, what do you mean by the closed under? Set of integers is closed under addition. That means if we take two integers and sum of this or add this, you will again get a integers, not any other number. If it is happening, then we can write down Z comma plus this structure. When we structurize this in that format within a bracket and between them there is a comma, we call it a groupoid. What we will call it? We call it a groupoid. I think this part is clear. Now, all of you please think of that set of natural numbers is closed under subtraction. You think it yourself. We will go to the next slide. Next one is, and the previous answer you will reply back me in the comments. Okay, next one is, first we will know that the group point, right? Now, tell me one thing. If we add up this, what will be the answer? Sorry, the answer will be 10. Now, if we add up this, the answer will be 10. So, can we write down this? Now, this changing the position of bracket, it has a specific name. This is called the associative property. This is called the associative property. Any set G, if it satisfies the associative property and it is closed under that operation, then these two property together we call it a semi-group. This is the second property. After that, we will call it a semi-group. Third one property. What is the third one property? Third one property is 2 plus 0 equal to 2, or 2 into 1 equal to 2. That means if you add some number to another number and you will get back the same number, this element is called the identity. If you product with some number and you will get back the same number, it is called the identity. That means we call this property name existence of identity. Right? And if this third property is also satisfied with along with the previous two, we call it a monoid. Fourth one. Fourth one is called the existence of inverse. Now, if you add -2 with 2, you will get 0. 0 is the identity element. If you multiply 2 with half, then you will get 1. That is the identity element. That means, if for each element there exists an inverse, for each element there exists, for each element A, there exists an element A inverse such that A inverse, if we consider this is the star equal to E, then this is called the existence of inverse for each element. If this four properties satisfied, we call the set is a group. So in the next part, we will briefly write down all the properties of a group. Right? So we will now give the formal definition of a group. So G be a non-empty subset, star be any binary composition defined on it. Then if G satisfies the following condition, condition 1, A star B belongs to G for all AB belongs to G. That means if we consider this star is a plus, sum of all the real numbers is a real number. This is the closedness property. Or you can say the closure property. If it is true, then we call it groupoid. This is the term if rule number 1 or the condition number 1 is satisfied. Next one, for all ABC belongs to G, we are considering here the general definition. A star B star C equal to A star B star C. This is called the associative property. This is for, if this is satisfied, then we call semi-group. Third one, A star E equal to A for all A belongs to G. Existence of identity. If it is satisfied, then it is called monoid. And last one, the for all A belongs to G, there exists an element A dashed belongs to G such that A star A dashed equal to. If this 4 condition are satisfied, we call then G comma star is a, when it is called an abelian group, if A star B equal to B star, it is called abelian group or commutative group. Next, we will solve a example, that is now we will consider the set of non-singular matrices of 2 cross 2 order, which forms a group under the matrix multiplication. Moreover, this is a non-abelian group, as we know that the matrix multiplication is not commutative. This is actually a non-abelian group. We will prove this one by one. First property, we have to check that this is a closed. Let A1, B1, C1, D1 and A2, B2, C2, D2 belongs to M. Now we will take the matrix multiplication. After multiplying, we will get A1, A2 plus B1, C2, A1, B2, B1, D2, C1, A1, C1, A2 plus D1, C2, C1, D2 plus D1, D2, right? After multiplying these two matrices, we will get this. As these all are integer, this is obviously an integer. So this is also belongs to M. And now AD minus BC is nothing but the date. So if date of this matrix, if we consider it as A and consider it as B, so date of AB equal to, we know that date of A into date of B. As this is non-zero, this is non-zero, so totally this is non-zero. That means its determinant is also non-zero. So this matrix multiplication AB belongs to M. So first condition is satisfied. That means M is closed under multiplication. Just you have to follow this way to write, to show a set is a group. This is the first one. Next is the associative second property. So we'll write down as matrix multiplication is associative so it is associative on M also. That means the given set. Third one, A, B, C, D. We will take, we know that the identity element 1001, that is the I2. If you multiply this, you will get the, and its date is also, date of this I2 is also 1, that means not equal to 0. That means identity element exists in M. Fourth one is the inverse. We know that data not equal to 0, as data not equal to 0, that means A inverse exists. Data not equal to 0 means A inverse exists. And A into A inverse is always date of I2. We know that. This is the property of the matrix. That means date of A inverse is also non-zero. That means A inverse belongs to your M set. So we will show that A inverse exists and A inverse belongs to M. So fourth property is also satisfied. That means M comma matrix multiplication is a group. And as the matrix multiplication is not commutative, so this group is not commutative or not abelian. This group has a specific name. This is called GL2R. Why it is 2R? Actually, this is a 2 cross 2 matrix. That's why it is 2. And its elements are comes from the set of real numbers. That's why it is called GL2R. General Full form is general linear group of ordered group taken from the real number. Hope you can understand this class. If you are like these classes, so please stay with us.